Welcome back, Calculus. We're going to finish our notes. This is the very last section, and we're going to be messing with inverse trig functions. So as we start this, we're just going to refresh our memory that we can take the derivative of all of these. And so as a reminder, the derivative of sine is cosine. The derivative of secant, and you can obviously work this out if you want to do the quotient rule. But most people will memorize that the derivative of secant is secant times tangent. And then the derivative of tangent, again, you can do the quotient rule if you really want to. Otherwise, a lot of people will memorize that the derivative of tangent is secant squared. So again, a lot of people will memorize those three. But the reason why I bring that to your attention is because then what we can do is we can find the derivative of y with respect to x of inverse sine. And so what I'm trying to get out of this is that you understand is instead of memorizing these rules, which some people do, what they'll do is they'll solve for x and then do implicit differentiation. So kind of just jotting down some notes here. And then implicit differentiation. Otherwise, you can memorize these rules. I'm not saying you can't memorize things. It's your choice. But if I asked you for the derivative of this, you would hopefully say it's cosine of y times dy dx. And on the right side, you'd say, oh, the derivative of x is 1. And so what that means is dy dx is equal to 1 divided by cosine of y. But we want to answer this in terms of x. So if I go back to this statement right here, let me put a box around it. That's not my final answer. I just want to go back to that original statement. Because remember, sine is defined as opposite over hypotenuse. So that means, as far as an angle goes, x is the opposite, and 1 would be the hypotenuse, which is why I have this triangle drawn down here, where I have angle y. This is supposed to be a right triangle. Is equal to, x is the opposite, 1 is the hypotenuse. So if I do the Pythagorean theorem, we'll call this side length, I don't know, a, although, yeah, that'll be fine. So a squared plus x squared would equal 1 squared. So that means that a squared would equal 1 minus x squared. So that means that a is going to equal the square root of 1 minus x squared. And why am I asking you to do that is because cosine of y, what's written right here, is equal to adjacent over hypotenuse. So what I'm saying is the correct answer is 1 over the square root of 1 minus x squared. That is the answer to the derivative of the inverse sine. And one more thing I should mention is sometimes this is written as arc sine, in case you missed that from a previous lesson, previous year, something like that. So I'm going to explain number 5 and number 6 as well. I'm just going to point out for you is I already have all of the integrals written out for you. And so why did I only write down the integral is because if I asked you for the derivative of arc sine of u, we can work backwards. And you can see it's 1 minus, 1 over the square root of 1 minus u squared. It's just the derivative I copied off of, which is exactly what I have written as my answer here. The reason why we use u, though, is because you do have to follow the chain rule. So if this said y equals inverse sine of 3x, your answer would be the same. It'd be the quantity of 3x squared times the derivative of the inside, which would be times 3. And maybe I'll even work through that, just kind of giving you another example. Find the derivative of, I'll write it as arcsine, just to give you something different, of 3x. So by the rule, you would say, okay, well, it's 1 over the square root of 1 minus the quantity of 3x squared, and then multiplied by the derivative of the inside because of the chain rule, so times 3. Or you can rewrite it like this. So here's just like an extra problem if anybody wanted to see it worked out slightly different. Yeah, I think that's a good enough explanation. So I could do the same thing with this problem, where you take the secant of y is equal to x. But this one's a little bit more complicated because if you take the derivative of secant, you get secant tangent dy dx is equal to 1. So then dy dx will equal 1 over secant y tangent y. Now the thing is we already know what secant of y is equal to. Secant of y is equal to x. So we're looking at 1 over x. We don't know what tangent of y is though. So what I can do is create another triangle very similar to how I created this triangle over here. I'm going to try and squeeze it right here though. Because remember, secant is the reciprocal of, so put a y right here, just like I drew this triangle. Secant's the reciprocal of cosine, so instead of x being the adjacent over 1, the hypotenuse, 1 is the adjacent, and x is the hypotenuse. So a little bit differently than how that triangle was, but just like before, I can call this side length some letter, so I can then say 1 squared plus b squared is equal to x squared. So if I solve for b, it'd be x squared minus 1, and then square root it. So that's why this, and remember tangent is opposite over adjacent, so tangent's defined as just b, and b equals the square root of x squared minus 1. Remember, if you are confused by anything, write down your questions. Bring your questions to class. I'm just trying to explain these rules to you instead of just saying memorize. So often I was taught to just memorize, but you can see then, let's see, this one. Notice there's a reason why we have the absolute value. And instead of x, the problem uses u. But you can see how it's worked out that way. I should have mentioned that this column over here of work is explaining why, explaining the chain rule, excuse me. That's what this is doing. So a would be a constant in this problem, and notice we're doing the antiderivative with respect to u. So again, if you have any questions, please, please, please write them down and bring them to class so I can answer them. And I can explain tangent the same way. So as I go back and explain tangent, let's see, I haven't used black yet. I'll just do black. So tangent of y is equal to x. The derivative of tangent is secant squared of y dy dx. The derivative of x is 1, so that means dy dx needs to equal 1 over secant squared of y. And by definition, tangent of y is equal to x over 1. So if I draw a triangle, I'm just going to sneak it right here. Poorly drawn triangle. Right here is y. Tangent is x over 1. So if I did the Pythagorean theorem, 1 squared plus x squared square rooted would give me the hypotenuse. And so secant is like hypotenuse over adjacent, except we need to square this piece because it's secant squared. So we're looking at 1 over 1 plus x squared is the derivative of that last one, which is shown on the next slide. So at any point you might want to hit pause, make sure you understand all of this, or memorize these rules. So if you noticed in all the problems I did, I strategically left off a few trig functions. So instead of asking you to memorize even more things as far as the integral goes, what I wanted to point out is that if you're ever asked to do the integral of 1 over the square root of 1 minus x squared, it is inverse sine of x plus c. The only difference is if we have a negative in front, everything else is the same. So basically what this boils down to is that the integral of, well, I guess another way of saying this is instead of ever writing this answer down, or cosecant or cotangent, what you can do is you can just say that this piece is equal to the negative, because we can move constants in front, of 1 over the square root of 1 minus x squared dx, which means that is equivalent to negative inverse sine of x plus c. So I guess that's where we're coming from. So on an AP exam, if they ever ask you for any integral of these inverse trig functions, the only options they'll give you will be arcsine, arctangent, or arcsecant. And that's the same thing that occurs for tangent, cotangent. So instead of writing this down, I'm just going to tell you that if I had arc cotangent, there would be a negative in this problem. And so the negative of this is arc cotangent of u plus c. And same thing with arc cosecant would be a negative in front. But again, you will not see that. You should not see that as well, as is what I'm saying. So just a few examples here is making sure that you're good with the derivative and pointing out the chain rule. So if you memorize these, that's fine. But what I'm trying to say is that you better do the chain rule, that it's 2 inverse cosine of x to the first power, but then you have to do times the derivative of arc cosine, which if the antiderivative of this gives us arc cosine, then the derivative of arc cosine gives us that value. So times negative 1 over 1 square root, forgot to write square root, of 1 minus x squared. And then how do we change it just ever so slightly is sometimes the chain rule is on the inside. So the derivative of this piece is, well, let's go back to our rules in case you're not comfortable with them yet, is it's the chain rule. So it's 1 over 1 plus that quantity squared. 1 over 1 plus that quantity squared. So you leave 5x squared minus 3 alone, but then times the derivative on the inside, which would be times 10x. And then just one more problem, and depending on how comfortable you are with memorizing, you can come up here and see which one looks like, the function we're looking at, and I'm looking at that square root of 1 minus x squared. So it looks like arcsine, except there's a 3 in front. But remember, that 3 can just be moved in front. So it makes perfect sense to me that this derivative, antiderivative, would be 3 arcsine of x. And don't forget about because it's an indefinite integral, that we need a plus c. Now I'm running out of time, so I do want to point out, now I'll finish these examples in a second video, that I'm only assigning the odd numbered problems from the CUDA software assignment that's in the folder. And all of the answers are in there. And then if you continue in these notes, I already have the answers. So if you want to see them worked out a little bit differently, I do have these answers inside of this packet of details. So I'll see you in the next video to finish up examples 5 through 8.